Hello, and welcome to Summarize Science. If you have a modern car, you've probably been startled by a collision warning when there was no real danger. It's a huge problem called false alarms, and it makes these safety systems less trustworthy. A new paper introduces an AI system called BADAS, designed to fix this by being much smarter about what a real threat is. The core problem is that current systems can't distinguish between a crash that involves your car and one that's just happening nearby. As you can see in these images, an accident in an adjacent lane is visually dramatic but irrelevant to your safety. Researchers call this the ego-centric problem. They reevaluated old datasets and found a shocking number of these irrelevant accidents, sometimes over 90%. This flawed data is exactly why current systems get it wrong so often. So, how did they solve it? They trained BADAS on a new, high-quality dataset from Nexar filled with thousands of real-world dashcam videos of collisions and near misses that only involved the driver's own car. The system uses a powerful modern AI architecture designed for understanding video. They even created two versions, a public one trained on 1,500 videos and a commercial one trained on a massive 40,000 videos. The results are a massive leap forward. This table shows that across 4 different benchmarks, both versions of BADAS dramatically outperform other academic models and even a commercial forward collision warning system. These graphs also show how BADAS's predictions are stable and confident as a collision approaches, while others are erratic and unreliable. This stability is key to reducing false alarms in the real world. Its timing is also much more realistic, giving alerts 3 to 5 seconds before an impact, which is similar to a human's reaction time. One of the most interesting findings is that more data makes a huge difference. This graph shows a clear, logarithmic improvement in performance as the training dataset grows from 1,500 to 40,000 videos. This suggests we haven't even hit the limit of how good these systems can get with more real-world examples. So, let's recap the big takeaways. First, for a collision warning system to be useful, it must focus only on threats to your own vehicle. Second, training AI on high-quality, relevant, real-world data is far more important than just having a complex algorithm. This work provides a blueprint for creating smarter, less annoying, and ultimately safer driver assistance systems. In the future, this approach could be crucial for developing truly reliable autonomous vehicles that can navigate complex traffic scenarios. Thanks for watching Summarize Science.